In this video, I will demonstrate how to solve numerals on projectile motions. I have taken two very simple numerals, right, and we'll try to solve them over here. Just for reference purpose and for revision purpose, I have written down also the three equations that we use for projectile motion. The total time taken for the entire journey is 2u sine theta upon g. H is the maximum height to which the object rises, and r is the range, right? And these are the three equations which you may use while solving these questions. Let us take the first one. An object is thrown horizontally from the top of an 85-meter tall building. Right? If the object hits the ground 67.8 meter from the base of the building, what was the horizontal velocity of the object? So we have a situation like this, that if this is the ground and this is the building which has got a height of 85 meter, right? An object is thrown horizontally, right? So that means it starts off from here in the horizontal direction and then comes and hits the ground. This is the ground. And this is the projectile motion of the object starting horizontally and then coming down like this. And the range, this r, is 67.8 meter. Right? So we've been given these two things, the height of the tower, the height through which the object falls, and r, and we're expected to find out the horizontal velocity of the object. Right? Now we can start by using h is equal to u square sine square 2 theta j upon g, and r is equal to u square sine 2 theta upon g. Let's see how we first we'll start with h. Right? We know that the height, the height through which this object falls, h, is also given by half g t square, right? Because when it is falling down, its initial velocity in the downward direction is 0. There is horizontal velocity ux, right, which we have to find out. Uy is 0, right, and h is equal to half gt square, right? This comes from s is equal to ut plus half gt square. Since the initial velocity is 0, we get half gt square. Now h is known, 85 is equal to half into 9.8 into t square, right? Therefore t square will be 2 into 85 over 98, right? And from this I'll get the value of t. Let me actually calculate it. So if I get it, 2 into 85 divided by 9.8 is 17.34, and if I do square root of that, I should get 4.1 second. So I have obtained the value of the time the object gets to reach the surface of the earth. The second thing that we know is r, and we also know that r is equal to ux, which is the horizontal velocity which remains constant in projectile motion, into the time of the journey, right? So r is ux into t. R is given to us as 67.8. ux we have to find out, and time of the journey is, we have found out, 4.16 seconds. From this, if I get ux is equal to 67.8, 4.16, 67.8 divided by 4.16 will give me 16.29 meters per second. Right, so this is the initial velocity. We have answered this question. The horizontal velocity is 16.29 meters per second. Right, so let's add over here. These are the two more equations which use x into t, and h is equal to half gt square. Of course, this is used when initial velocity is 0, when the object is only when uy is 0. Right? So this is how we will look at this particular question. Let's move on to the next question. In this question, an object is thrown in air at an angle of 37 degree. So the initial angle theta is 37 degrees. If its initial velocity is 18 meters per second, u is equal to 18 meters per second. How far will the object be in air? How far will it travel before it hits the ground, and how high it will go? Right. So we have this particular situation. The object is thrown and it completes projectile motion and falls over here. If this represents the initial velocity u as 18 meters per second, this angle is 37 degree. How far will the object be in air? For how long will the object be in air? Actually, this should have how long. So we will have to find out time t, and we know time t is 2u sine theta by g. So if I take t is equal to 2u sine theta by g, that should be 2 into 18 into sine 37 by 9.8. Do a quick calculation with this. Sine of 37 is 0.60, 36, and divided by 9.8 will give me 2.21 seconds. 2.21 seconds. So that's the first question that we have answered. How far will it travel before it hits the ground? That means we have to find out the range r, and we have again an equation for range r. Range r is given by u square sine 2 theta by g. So again I'll simply have to substitute those values. U is 18 into 18 sine 2 into 37 upon 9.8. Therefore r will be, let us calculate this, 37, 74, sine of 74 will be 0.96 multiplied by 18 divided by 9.8, and that would be 31.78 meter. So we have found out r. How high will it go? Means we will find out h. This is h we need to find. We have already found out r. This is r found out. Now let's find out h. Again, simple application of the formula. H is equal to u square sine square theta by 2g is equal to 18 into 18 into sine square 37, 2 into 9.8. Again, we will quickly do a calculation. That sine of 37, 0.60 multiplied by 0.60 multiplied by 18 multiplied by 18 divided by 19.6 will give me 5.96 meter. Right. So this is what so these are the three things that we were asked to find out, and we have looked at this, all the parameters that we were expected to find out in this question. So these are the three formulas that you will use, and apart from that, r is equal to ux into t, and basically it is about trying to find out what is given and then what is not given, and then playing around with these equations, and you will be able to solve most of the questions that you have for projectile motions. In the next video on projectile motion, I'll take a numerical in which we will be trying to deal with a question wherein the object is not completing this journey. The object is, maybe stopping its journey over here. There is, say, for example, a building over here. So the object is thrown from here and reaches over here. In that case, how to deal with time taken, how to deal with the velocity over here, how to deal with the height that is reached over here from the ground. We will look at that in the next video. Thank you.